Welcome. In this video, we are going to take a look at problem 21. It is from chapter 3 of College Physics 2E by OpenStax. In this problem, we're flying in a plane. Okay, and so we're going to fly a total of 32 kilometers, and then we're going to fly, first we're going to go 35 degrees south of west, and then what we need to do is find the distances we would have to fly to go straight south and then straight west. And then in part B, we're going to rotate the axes. Okay. So let's draw the picture of what's going on. Okay, so here's our north, south, east, and west. And so we are flying 35 degrees south of west. So there's our 35 degrees south of west. And then this length is 32 kilometers. And let me just move this down a little bit. We'll just extend this. Okay, so that makes that angle also 35 degrees because the west displacement is parallel to the east-west line. And this would be our south. So we'd go south, and then we'd go west, and we'd arrive at the same point. Okay, so I think we can fit that right here. So if we take the sine of the 35 inside the triangle, (35°), we're going to get the opposite side, the r south, over the hypotenuse, which is the total displacement, the 32 kilometers, let's just call it r. And so then the south, so flying directly south, will be r times the sine of 35. So we will have the 32.0 kilometers times the sine of 35 degrees. And the south part would be 18.35 kilometers. And so that would be 18.4 kilometers. So we would need to fly 18.4 kilometers south. Now, if we take the cosine of the 35 degrees, that's going to be the adjacent side, the western displacement, so the r west over the total r. And so the western leg would be r cosine 35 degrees. So that's going to be the 32 kilometers times the cosine of the 35 degrees. And that gives 26.21 kilometers. And so the western leg would be 26.2 kilometers. So to get to the same point, we could fly 18.4 kilometers south and then 26.2 kilometers to the west. Okay, so that's all part A. Now in part B, we need to find the distances you would have to fly first in a direction 45 degrees south of west, then in a direction 45 degrees west of north. These are the components of displacement along a different set of axes, one that's rotated 45 degrees. Okay, so let's draw a new picture. All right, and so This time we want 45 degrees. Okay. And originally, I'm going to exaggerate this, we went 35 degrees. So that makes this bit 10 degrees. Okay. And so we want to get to, say, that point there. And so I'm going to call this the adjacent displacement. I'll call it D sub A. And then I'm going to call this the opposite displacement, D sub O. And then this will be 90 degrees here. And so to convince you of that, we can think of a straight dotted line. So here we got 45 here, so we've got 45 here. And then we are going to have 45 here, because we are going 45 west of north. Okay. And so let me just highlight. Here's the original path. All right, so we are still going the 32 kilometers. We still want to end up in the same spot. It's just that we're taking a different path. All right, and so now we can take we're going to concentrate on that 10 degrees. So we can take the cosine of the 10 degrees, and we're going to get the adjacent side, which is our adjacent displacement, so what I'm calling dA. And then this will be over the original r. I'll just put in the 32 kilometers. Okay. And so the adjacent displacement is the 32 kilometers times the cosine 10 degrees. And this gives us 31.5 kilometers. Okay. And now if I take the sine of the 10 degrees, I get the opposite displacement, so d opposite, or dO, over the 32 kilometers. And dO is going to be 32 kilometers times the sine of 10 degrees. And so now our opposite displacement is 5.56 kilometers. So if we rotate by 45 degrees, we've got 10 degrees left. And so now we're going to be going 31.5 kilometers along dA, and then 5.56 kilometers along dO, and we arrive at the same location as we did the first time. Okay, I hope you found that helpful. Let me know in the comments section if you have any questions. Thank you for watching, and I'll see you in the next one.